What if time isn't a straight line but something more flexible? Something that under the right conditions could fold, twist, or even repeat? Scientists have explored this idea through Einstein's relativity, quantum mechanics, and theories of closed time-like curves. Some believe time loops are purely fiction, others think they could be hidden in the very fabric of reality. So let's dive deep into the theories, paradoxes, and real-world experiments that just might prove that time loops aren't just Hollywood magic, they could be real. Time loops. Imagine waking up to the same morning over and over again, every action you take, every word you speak, every choice you make resetting like a broken record. Sounds like science fiction, right? But what if I told you some of the brightest minds in physics have seriously considered the possibility that time itself might not always flow in a straight line? Instead, it could loop, bend, or even fold back on itself, trapping events in an endless cycle. We've all seen movies and shows where characters get stuck in a time loop, repeating the same day, trying to break free, or using their knowledge of past loops to their advantage. But is this just a Hollywood fantasy, or could the fabric of time actually allow for such strange phenomena? Could time loops be real? Could you, in some bizarre twist of physics, find yourself reliving the same moment indefinitely? The idea of time loops isn't just some wild storytelling device. It has roots in deep scientific theories, some of which suggest that under the right conditions, time might not be as linear as we assume. From Einstein's relativity equations to the mind-bending possibilities of quantum mechanics, certain interpretations suggest that time loops might not be entirely impossible. In fact, some theories imply they could already be happening, hidden from our everyday experience. But before we dive into the theories and research, let's break down what a time loop actually is. Is it a glitch in the universe, a natural occurrence, or just a human illusion? Let's find out. Gödel's rotating universe. What if I told you that, mathematically speaking, time travel might already be possible, at least on paper? In 1949, the legendary mathematician Kurt Gödel proposed something that could rewrite everything we think we know about time. He wasn't just any mathematician, this was the same genius behind Gödel's incompleteness theorems, which shook the foundations of mathematics itself. And when he turned his attention to Einstein's general theory of relativity, what he found was nothing short of mind-blowing. Gödel discovered a solution to Einstein's equations that described a rotating universe, a cosmic dance where space and time weren't just linear, but could actually loop back on themselves. In this model, time wasn't a one-way street, it was a circular highway where, theoretically, you could travel along a certain path and end up in your own past. Yes, that means time loops could be a built-in feature of our universe, if Gödel's model were correct. So how does it work? Imagine the entire universe spinning like a giant whirlpool. As space twists, time gets caught in the motion, forming what physicists call closed time-like curves, CTCs. Pathways where an object or person could move through space-time and arrive at an earlier point. This essentially creates a time loop, a scenario where past and future aren't strictly separated. But before you start making plans to visit ancient civilizations, there's a catch. Gödel's universe requires a very specific type of global rotation, one that doesn't match our observations of the real universe. Modern cosmology tells us that while the universe is expanding, there's no clear evidence that it's rotating in the way Gödel's equations describe. So does this mean time loops are impossible? Not necessarily. Gödel's work showed that time itself might be more flexible than we assume, opening the door for other theories that could one day prove that loops in time are more than just science fiction. Closed time-like curves. What if time wasn't a straight path but a loop? What if you could take a walk through space-time and, instead of moving forward into the future, you ended up back in your own past? Sounds crazy, right? But according to some interpretations of Einstein's theory of general relativity, this might not just be possible, it could be a fundamental feature of the universe. Enter closed time-like curves, a theoretical concept that allows time itself to twist and reconnect, forming loops that could trap events in an endless cycle. Imagine drawing a timeline on a piece of paper. Now, instead of keeping it straight, you bend it into a circle so the starting point eventually connects back to itself. That's a CTC, a space-time path where an object, or even a person, could travel and end up exactly where they started, but at an earlier point in time. This isn't just a thought experiment. Solutions to Einstein's field equations actually allow for CTCs under specific conditions. One of the most famous examples is Gödel's rotating universe, which showed that if the universe had a certain type of spin, time loops could naturally form. Other proposals like wormholes and rotating black holes also suggest that if space-time were bent the right way, closed time-like curves might emerge. But here's the big question. If CTCs exist, why don't we see time travelers popping up at random? That's where things get tricky. Some physicists argue that nature might have built-in safeguards to prevent time loops from forming freely. Stephen Hawking's chronology protection conjecture suggests that quantum effects could destroy any time loop before it fully forms, ensuring that paradoxes never occur. Still, the fact that CTCs are mathematically possible raises a profound question. If the universe can allow time loops, does that mean they exist somewhere out there? Or are we just scratching the surface of something far bigger than we can comprehend? Novikov's self-consistency principle. Alright, let's say time travel is possible. You step into a time machine, travel back a few decades, and decide to change history. Maybe you want to stop a major event from happening, or classic time travel trope, you prevent your grandparents from meeting. Boom! You've just created a paradox, a contradiction that could break the very fabric of reality. But what if I told you that some physicists believe time itself wouldn't allow such paradoxes to exist? Enter the Novikov self-consistency principle, the ultimate rule book of time travel. Proposed by Russian physicist Igor Novikov in the 1980s, this principle suggests that if time loops exist, the universe has a built-in mechanism to prevent paradoxes. In other words, no matter what you try to change, history will self-correct so that the timeline remains consistent. It's like the universe is running an autocorrect feature for reality. Whatever you do in the past will always align with events that have already happened. Let's break it down. Imagine you travel back in time to prevent an invention from being created. According to Novikov, something will always interfere. Maybe you accidentally inspire the very invention you were trying to stop. The loop stays intact, and history unfolds exactly as it was meant to. The past is flexible only in ways that keep it logically consistent. This principle has huge implications. It suggests that time travelers aren't free agents. They can't just alter events on a whim. Instead, they become part of history, playing the role they were always destined to play. And here's the kicker. If time loops exist, they must already be playing out around us without causing contradictions. So could time loops be real? If they are, Novikov's principle suggests that we might never even notice. The universe might be a master of self-correction, ensuring that time remains an unbreakable, logical chain. No paradoxes, no rewrites, just one seamless, unchangeable loop. Chronology protection conjecture. Imagine a world where time travel is not only possible but common. People from the future randomly show up in the past, rewriting history, creating paradoxes, and leaving behind a tangled mess of cause and effect. Sounds chaotic, right? Well, according to Stephen Hawking, nature simply wouldn't allow such a disaster to unfold. His answer? The chronology protection conjecture, a theoretical safeguard built into the fabric of the universe to prevent time loops from ever forming. Hawking proposed this idea in 1992, suggesting that while Einstein's general relativity allows for solutions like closed time-like curves, CTCs, which could theoretically permit time travel, something in the laws of physics steps in to prevent them from becoming reality. Essentially, the universe acts like a self-policing system, making sure no one can break causality or rewrite history. But how does it work? One possibility is that the moment a time loop begins to form, quantum effects kick in and destroy it before it becomes stable. Some theories suggest that vacuum fluctuations, tiny, unpredictable quantum changes in spacetime, would build up to an infinite level near a time loop, ripping it apart before it can be used. Others believe that gravity itself could create an instability that prevents time travel from ever happening. So, if Hawking was right, this means that even if we discover a theoretical way to travel back in time, nature will always find a way to shut it down. No paradoxes, no rewriting history, no alternate realities, just one continuous, untouchable timeline. But here's the real question. What if the chronology protection conjecture isn't an absolute law, but just a tendency? Could there still be hidden loopholes, conditions where time loops might briefly exist before collapsing? If so, the universe might not be as rigid as we think, and the dream of traveling through time might not be entirely impossible. Experimental investigations. Alright, we've talked about theories, Gödel's rotating universe, closed time-like curves, and even Hawking's idea that time travel is off limits. But what about real-world experiments? Has anyone actually tried to prove that time loops could exist? The short answer? Yes. And some of the results are surprisingly intriguing. One of the most well-known names in this field is Dr. Ronald Mallet, a physicist who has spent decades working on a theoretical time machine. His idea? Using ring lasers to create a circulating beam of light strong enough to twist space-time itself. If space can be bent, and time is linked to space, then maybe, just maybe, a powerful enough laser could create a closed time-like curve, making time loops possible. While Mallet's work is still in the theoretical stage, it's one of the few serious attempts to explore time loops in the lab. But lasers aren't the only approach. Some physicists have looked at the quantum world for answers. In 2014, a study simulated photon-based time travel using quantum entanglement. Scientists at the University of Queensland managed to create a system where a photon, a particle of light, appeared to interact with a past version of itself, essentially behaving as if it were inside a time loop. While this wasn't real time travel, it hinted that nature might not completely forbid information from moving in strange loop-like ways. Then there's the research on black holes and wormholes. Some theories suggest that rotating black holes like Kerr black holes could naturally create conditions for time loops to exist. The challenge? We can't exactly step into a black hole and check. However, astronomers are constantly studying the effects of black holes on space-time, looking for signs that time behaves differently near their event horizons. So, what's the verdict? We don't have a working time loop yet, but experimental research is pushing the boundaries of what we know about time. Could future discoveries reveal that time loops are not only possible but already happening around us? Science isn't ruling it out just yet. Time loops in fiction versus reality. We've all seen it in movies. The protagonist wakes up, lives their day, something bizarre happens, and then boom! They're back at the start, trapped in a loop. Whether it's Groundhog Day, Edge of Tomorrow, or Tenet, time loops have become a storytelling goldmine. But here's the big question. How close is Hollywood's version to scientific reality? In fiction, time loops often work as a reset button, forcing characters to relive the same moment until they break the cycle, whether through self-improvement, solving a mystery, or fulfilling some cosmic purpose. But in real physics, time loops, if they exist, wouldn't necessarily follow a narrative arc. Instead of a magical force trapping someone until they learn their lesson, time loops in nature would be an inherent feature of space-time, a direct consequence of Einstein's equations, quantum mechanics, or even higher dimensional physics. So, could someone actually get stuck in a loop like in the movies? If closed time-like curves (CTCs) exist, it's theoretically possible that information or even conscious beings could experience cyclical time, constantly returning to the same point. But here's the catch. Novikov's self-consistency principle suggests that any action taken in a time loop must be consistent with history, meaning you wouldn't have free will to break out of it. And then there's Hawking's chronology protection conjecture, which suggests time loops should be physically impossible, nature's way of keeping history untouchable. That means no respawning, no rewinding, and no magical resets. So, while fiction lets us fantasize about infinite do-overs, reality is a bit more stubborn. Time loops may not follow Hollywood rules, but who knows? The universe still has plenty of secrets left to uncover. Maybe one day, science will reveal that fiction wasn't too far off after all. So, could time loops really exist? Or are they just a wild sci-fi fantasy? While science hasn't confirmed them yet, theories suggest they might be possible under extreme conditions. Maybe the universe is hiding its biggest secrets in the folds of time itself. What do you think? Are time loops real, or just a mathematical illusion? Let me know in the comments. And if you love exploring the mysteries of time and space, don't forget to subscribe to InnoVision Tech. Imagine a universe so bizarre that even science fiction can't keep up. Planets where it rains molten glass, worlds blacker than coal, and even rogue planets that drift alone in the dark. These aren't fantasy, they're real. Today, we're diving into 7 of the strangest planets ever discovered. Each one is weirder than the last, and trust me, by the end, you'll be questioning just how strange the universe can get. Buckle up, this is going to be mind-blowing. HD 189733b. Imagine stepping onto a world where the sky is a stunning deep blue, like a tropical paradise. But don't be fooled, this is no vacation spot. This is HD 189733b, and it will shred you to pieces before you can take a single step. Located 64.5 light-years away, this exoplanet may look beautiful from a distance, but its atmosphere is a brutal war zone. The winds here roar at over 5,400 miles per hour, that's 7 times the speed of sound. And if that isn't terrifying enough, those winds are carrying shards of molten glass blasting through the air like nature's own sandblaster. Imagine a never-ending storm where the rain doesn't just soak you, it slices you apart. But how did it get this way? Well, its hellish weather comes from its extremely close orbit to its star, which superheats its atmosphere. The intense heat evaporates silicate particles, which later cool and form glass droplets, only to be swept sideways by the extreme winds. And that deep blue color, it's not from a peaceful ocean. Scientists believe it comes from the silicate particles reflecting blue light. So, while Earth's blue skies come from a scattering effect in our gentle atmosphere, HD 189733b's blue comes from something much more violent. A world of razor-sharp rain, hurricane-speed winds, and scorching temperatures. This planet is as deadly as it is mesmerizing. TOI 849b. What if I told you there's a planet out there that lost everything except its heart? That's TOI 849b, a world that shouldn't exist, yet it does. This exoplanet, sitting 730 light-years away, is thought to be the exposed core of a former gas giant. Imagine Jupiter stripped of its atmosphere, left bare and vulnerable. That's TOI 849b. It's 3 times the mass of Earth but far denser, suggesting it was once covered in thick, swirling clouds of gas, just like our own gas giants. But something catastrophic happened. Did its star rip away its atmosphere over time? Was it the result of a violent planetary collision, or did it somehow fail to develop a proper atmosphere in the first place? Scientists still aren't sure. But one thing's certain, this planet is a goldmine of secrets. By studying TOI 849b, astronomers have a once-in-a-lifetime chance to study what's inside a gas giant, something we'll never be able to do with Jupiter or Saturn. What elements make up its core? What does a planet look like after it's been stripped to the bone? This planet is a ghost of what once was. A lonely, exposed core drifting in space, holding the key to the past of many gas giants. WASP-12b. Some planets are born to die, and WASP-12b is one of them. This doomed world, located 1,400 light-years away, is slowly being eaten alive by its own sun. Unlike planets that drift peacefully in their orbits, WASP-12b is in a death spiral, orbiting so close to its star that it completes a full orbit in just 1.1 days. That's right, 1 year on this planet is barely more than 1 Earth day. But that's not the worst part. The extreme closeness to its star means the planet is being pulled apart by intense gravitational forces. It's not a perfect sphere anymore. It's been stretched into an egg shape with gases being ripped away into space. Over time, its entire atmosphere will be consumed, and in about 10 million years, it will be completely gone. What's even stranger? WASP-12b is blacker than coal. It absorbs about 94% of all light that hits it, making it one of the darkest planets ever discovered. Imagine a world where no sunlight reflects back, a pitch-black dying planet, slowly being devoured by its own parent star. This is the ultimate planetary tragedy, a world that won't last. It's being erased from existence little by little, every single second. And one day, all that will remain is its star, glowing in the darkness, as if the planet was never there at all. Rogue planets. Imagine a planet with no sunrise, no sunset, no warmth, no star to call home. This is the fate of rogue planets, worlds that wander the galaxy alone. Unlike Earth, which orbits the sun in a predictable, stable path, rogue planets drift aimlessly through space, unbound by the gravitational pull of any star. Scientists believe these planets were once part of solar systems but were violently ejected, either from massive planetary collisions, gravitational chaos, or encounters with other stars. And the craziest part? There could be more rogue planets than stars in the Milky Way. Some estimates suggest trillions of these lonely wanderers are scattered across our galaxy. But what happens to a planet that has no sun? Without a nearby star, rogue planets don't have the luxury of sunlight. Their surfaces are shrouded in eternal darkness, frozen solid unless they have an internal heat source. But some could still support life. if they have a thick enough atmosphere or a hidden ocean under a layer of ice. Picture an entire Earth-like planet, floating in the void, never seeing daylight, its only light coming from distant stars. It's eerie, it's lonely, and it's out there right now drifting silently through the abyss. 55 Cancri E. What if I told you there's a planet out there that might be worth more than our entire planet combined? Meet 55 Cancri E, a world so extreme that scientists believe it could be made of solid diamond. This exoplanet, located 41 light-years away, is twice the size of Earth but nearly 9 times as dense. It orbits so close to its star that a year lasts only 18 hours, meaning it's locked in a never-ending inferno, with temperatures soaring over 4,000 degrees Fahrenheit, 2,200 degrees Celsius. That's hot enough to melt iron. So why do scientists think it's a diamond planet? Its composition suggests it has an unusually high carbon content, and with intense pressure and heat, carbon can transform into pure diamond. That means if 55 Cancri E really is carbon-rich, parts of its crust, mantle, or even core could be diamond. But before you start planning a space mining mission, there's a catch. Recent research suggests the planet may not be pure diamond but instead covered in magma oceans, making it more of a fiery hellscape than a sparkling gemstone. Still, whether it's a diamond treasure trove or a molten wasteland, 55 Cancri A is one of the most bizarre and valuable planets we've ever discovered. Tres 2b. Some planets shine, others reflect light. But Tres 2b does something even stranger. It absorbs almost all the light that hits it. This exoplanet, found 750 light-years away, is officially the darkest planet ever discovered, blacker than coal, ink, or even the blackest paint on Earth. Scientists were shocked when they measured how much light bounced off this planet. The answer? Almost none. Tres 2b reflects less than 1% of the light that hits it, making it darker than any known celestial body. It's like a giant black hole in space, except it's a planet. But why is it so dark? Its atmosphere contains chemicals that trap light, instead of reflecting it. Unlike Jupiter, which has bright clouds that make it visible from Earth, Tres 2b is a light-eating monster, covered in unknown gases and minerals that absorb nearly everything. The result? A world of eternal darkness, where the only glow comes from its faint red heat, barely escaping into space. If you stood on its surface, you wouldn't be able to see your own hand in front of your face, just an endless abyss of blackness. A world that swallows light itself. Tres 2b is the closest thing to a real-life dark void. Kelt 9b. Some planets freeze, others burn, but Kelt 9b, it doesn't just burn, it boils. This ultra-hot Jupiter, located 670 light-years away, is the hottest exoplanet ever discovered. How hot? A mind-melting 7,800 degrees Fahrenheit, 4,300 degrees Celsius, hotter than some small stars. This planet is so close to its sun that it orbits once every 1.5 days, and the heat is so extreme that its atmosphere is literally evaporating into space. Imagine stepping outside and watching the sky peel away into the cosmos. That's what's happening to Kelt 9b right now. Because of the intense radiation, even molecules struggle to survive here. Scientists believe that common elements like hydrogen and oxygen are being torn apart by the heat, making this planet's atmosphere unlike anything we've ever seen. And the worst part, it won't last forever. Over time, Kelt 9b will be completely stripped down, leaving behind nothing but a scorched planetary core, or maybe even disappearing entirely. A planet that burns hotter than fire itself, Kelt 9b is the ultimate cosmic inferno. The universe is full of mind-bending mysteries, and these strange planets are just the beginning. Which one blew your mind the most? Let me know in the comments. If you enjoyed this journey through the cosmos, don't forget to like, share, and subscribe to InnoVision Tech for more futuristic discoveries and space wonders. Hit that notification bell so you never miss an episode. Until next time, keep exploring the unknown because the future is limitless. Have you ever wondered what would happen if the sun just vanished? No explosion, no warning, just gone in an instant. Sounds like something out of science fiction, right? But let's think about it. For 8 minutes, everything would seem normal. Then, darkness, no sunrise, no warmth, just a world plunged into an eternal night. And that's only the beginning. Earth would break free from orbit, drifting into space. Temperatures would plummet, turning our planet into a frozen wasteland. Life would collapse, and humans, well, we'd have to fight against impossible odds to survive. So could we make it? Or would this be the beginning of the end? Let's find out. The first 8 minutes. Imagine this. One moment, the sun is shining, warming your skin, lighting up the sky, and then poof, it vanishes, just gone. No explosion, no warning. But here's the weird part, nothing changes. For 8 minutes and 20 seconds, Earth keeps spinning, birds keep flying, and the internet still works. Why? Because the sun's light and gravitational pull take time to reach us, exactly 8 minutes and 20 seconds at the speed of light. So, for that brief window, everything appears normal. The sun still looks like it's right there in the sky, but then, everything changes. Suddenly the world plunges into total darkness. No sunset, no twilight, just instant, all-consuming blackness. The sky, a gaping void, even the moon disappears because, guess what? It only shines by reflecting sunlight. And then gravity lets go. Earth has been locked in a gravitational dance with the sun for 4.5 billion years, but now, the music stops. No more central force holding us in orbit. We don't feel it, but at this exact moment our planet stops curving around the sun and shoots off into space, like a car suddenly skidding off a racetrack. But there's no panic, no alarms, no immediate disasters. For now, the only thing people notice is the pitch-black darkness, a night with no dawn. And in this eerie, unnatural silence, one terrifying thought starts creeping in. Something is very wrong. Earth breaks free. Imagine floating in space, untethered, weightless, completely free. Sounds peaceful, right? Now imagine Earth doing the same thing. But at 67,000 miles per hour. The moment the sun disappears, so does its gravitational pull. For over 4.5 billion years, the sun has held Earth in its invisible grip, keeping us locked in orbit like a cosmic leash. But now, that leash just snaps. At first, nothing feels different. You don't feel the planet moving, just like you don't feel it speeding through space right now. But make no mistake, Earth is now a runaway spaceship, no longer bound to its familiar orbit. Where do we go? Straight ahead. For billions of years we've been following a curved path around the sun, but with no sun pulling us in, we stop curving. Instead we shoot off in a straight line, hurtling into the void. Imagine spinning a ball on a string, then suddenly cutting the string. That's us now. A lonely, frozen marble drifting deeper into space. The moon? It sticks with us, for now. Since Earth's gravity still exists, the moon keeps orbiting like nothing happened. But over time, without the sun stabilizing things, the moon's orbit could become chaotic. It might spiral closer, or drift away forever. And here's where it gets terrifying. As Earth speeds into the abyss, we leave behind something irreplaceable. The one thing that has always been our anchor. The solar system, our home, fades behind us. We are no longer part of it. We are alone. Instant darkness. Imagine flipping a switch and turning off the sun. 1 second it's bright and warm, the next? Total, absolute darkness. No sunset, no gradual dimming, just an instant void, swallowing the sky whole. The moon? Gone. It only shines because it reflects sunlight, so now it's just a dead, invisible rock drifting through space. The blue sky? It vanishes too. Without sunlight scattering through the atmosphere, our world is suddenly cloaked in an eerie, star-speckled blackness, even during what should have been midday. But here's the weird part, not everything goes dark immediately. For a few hours the outer planets, Jupiter, Saturn, Neptune, Uranus, will still glow faintly. Why? Because they were far enough away that the last rays of sunlight are still traveling toward them. It's like watching fireworks. After the explosion, you still see the light for a moment before it fades. And then there's Earth itself. Cities? They still glow with artificial lights, street lamps, neon signs, flickering TVs. But out in nature, everything feels unnatural. Even if you light a fire, it doesn't feel the same. Shadows don't stretch the way they used to. There's no golden warmth, no dawn on the horizon, and the stars, they look different. With no sun overpowering them, the night sky is now insanely bright. You'd see distant galaxies, nebulae, maybe even planets from other solar systems. A beautiful sight if it weren't for the chilling realization that this is it. This is forever. Earth becomes a giant freezer. Darkness is one thing. Cold? That's a whole different nightmare. Without the sun's warmth, Earth becomes a dying ember in space. The heat we once took for granted now slipping away, second by second. The first day? Not too bad. The temperature drops, but thanks to our atmosphere trapping some heat, it's still survivable. Maybe you grab an extra blanket, turn up the heater and think, this isn't so bad. But by the end of the first week, you step outside and feel a deathly chill, colder than the coldest Antarctic winter. The average global temperature has plunged to around -73 degrees Celsius, or -100 degrees Fahrenheit. The air bites. Your breath turns to frost the moment it leaves your mouth. Rivers freeze, lakes turn to solid ice. And the ocean? It's starting to freeze too. At first, only the surface forms a thick, glassy layer of ice. But below, the water remains liquid, for now. The deep ocean holds on to heat like a massive thermal battery, buying time before the inevitable. But time is running out. Within a year, the entire planet is a frozen wasteland. The surface temperature drops to -200 degrees Celsius, so cold that even the air itself begins to change. Oxygen and nitrogen start to liquefy, coating the ground in a thin, eerie layer of frozen gas. The sky, empty, silent, lifeless. Earth is no longer a home, it's a drifting ice ball tumbling deeper into the void, and unless we find a way to escape, we're going down with it. The end of life. Life is resilient, but without the sun, it's on a ticking clock. Within days, plants start dying. No sunlight means no photosynthesis, the process that keeps them alive. First, the leaves wither, then the forests go silent. No buzzing insects, no rustling leaves, just stillness. A world that was once alive is now starving. Within weeks, the food chain collapses. Herbivores, deer, rabbits, even insects begin dying off. Predators hold out a little longer, scavenging whatever's left. But with every meal, they're simply delaying the inevitable. Soon there's nothing left to hunt. Humans, we're resourceful, but this isn't just a food crisis. It's a fight against the cold. Even with stockpiled supplies, even in heated shelters, every breath outside freezes in your lungs. Cities turn into ghost towns, buried under layers of ice. Electricity grids fail, and slowly, one by one, fires burn out. But here's where things get strange. Not everything dies. Deep below Earth's surface, some life doesn't even notice the sun is gone. Creatures in hydrothermal vents, blind shrimp, bacteria, and deep sea worms, thrive in the scalding heat from the Earth's core. They don't need sunlight, they never did. Microbes living in deep caves, trapped under glaciers, or buried beneath the ocean floor, they could survive for centuries, maybe even longer. Earth's surface may be frozen solid, but underground, life still clings on. The real question is, how long can we? Could humans survive? Humans are survivors. We've conquered ice ages, deserts, and disasters. But could we survive the death of the sun? At first, yes. Governments would declare emergencies and people would retreat indoors using backup power, stockpiled food, and whatever warmth they could find. Underground bunkers, nuclear power plants, and geothermal energy sources would become humanity's last hope. But let's be real, this is just buying time. The biggest problem? Food. Without sunlight, crops die. Livestock starves. Canned goods and frozen food last for months, maybe years, but eventually supplies run out. Hydroponic farms and lab-grown meat could keep some people alive, but only for so long. A long-term food source? That's a problem no one can solve. Then there's the cold. Even with heating, temperatures outside drop below survivable levels. Oceans freeze, air becomes too thin to breathe, and every step outside is a death sentence. Cities crumble under the weight of ice. Power plants fail, and nuclear reactors eventually shut down. Maybe a few thousand people survive in deep underground shelters, heated by the Earth's core. Maybe they last centuries, using technology, rationing supplies, and clinging to life, but at some point, Earth will be too cold, too airless, too dead to sustain us. The only real hope? Leaving. But with no sun, space travel is nearly impossible. No gravity assist, no energy source, no safe destination. Earth was always our home, but without the sun, it's just our tomb. So what do you think? Could humanity survive without the sun, or would Earth become a lifeless, frozen rock drifting through space? One thing's for sure, we owe everything to our star. If you enjoyed this mind-bending scenario, make sure to like, share, and subscribe to InnoVision Tech for more fascinating science and technology explorations. Got a wild what-if question? Drop it in the comments, we might cover it next. Until then, stay curious, stay innovative, and keep exploring the unknown.